Here it says 6 students are in a race. Ken's probability of winning is 0.2. Lee is twice as likely to win as Ken. Roy is 1/4 as likely to win as Lee. And Tracy, James, and Katie all have the same chance of winning. Create a table of probabilities for the sample space. So first, I'm going to create the table, and there are 6 students, so I'll have 6 columns. Now let's write the names of the students across the top row. Now, it's important to note that there are 6 students in the race. So the winner is either going to be Ken, Lee, Roy, Tracy, James, or Katie. These are the only possible outcomes as the winner. So the probability of each of these people winning, if our probabilities are listed as decimals, these are going to all add up to 1. If the probabilities are listed as percents, these will all add up to 100%. So let's start filling them in. It says Ken's probability of winning is 0.2. So we're going to put that right here. Lee is twice as likely to win as Ken. So 2 times as likely to win. So I'm going to take Ken's probability and I'm going to multiply it by 2. And that's Lee's probability. How about Roy? Roy is 1/4 as likely to win as Lee. So we'll take Lee's probability, the 0.4, and we'll multiply it by 1/4, or divide it by 4. And that will give us Roy's probability. Then it says Tracy, James, and Katie all have the same chance of winning. So whatever goes here, here, and here is going to be the same number, but we don't know what it is. Remember, all of these probabilities, since we're dealing with decimals, are going to add up to 1. So we can just put a variable in there for now. Let's use P. And now we can use the fact that we know that all of these add up to 1 to create an equation. And now we can solve this equation for P and know then Tracy, James, and Katie's probabilities of winning. So to solve an equation, you first want to look at each side of the equal sign and see if there's anything that can be simplified. In this case, we have some like terms that we can combine. So if we add these together, we get 0.7. If we add these together, we get 3p. And on the right side, we still have a 1. Now, to solve for p, it's being multiplied by 3. We're adding 0.7. You always undo what's added or subtracted first. So I'm going to subtract that 0.7, and I end up with 3p equals 0.3. And what's the last step? Undo that multiplying by 3 by dividing both sides by 3, and we end up with p equals 0.1. And you can always test it out. If you add 0.2, 0.4, 0.1, 0.1, 0.1, and 0.1, you indeed do get 1. Let's do one more using percents instead. All right, here we go. This one is eerily familiar, but we're dealing with percents. Notice we have a 20% here. So this means that their percents of winning, if we add them all up, they add up to 100%. So let's quickly go through this. It says Ken's probability of winning is 20%. Lee is twice as likely to win as Ken. So we take 20% and we multiply it by 2 because they're 2 times as likely. Roy is 1/4 as likely to win as Lee. So we take that 40%, Lee's probability, and we multiply it by 1/4 or divide it by 4. And then again, Tracy, James, and Katie all have the same chance of winning. So their probabilities are all going to be exactly the same. We don't know what it is, so we're just going to use a variable. You can use any letter. I'm going to use P. So just like in the other one, but this one is percents, we know that all of these add up to 100%. So we create an equation. Instead of putting the percent symbol, I'm just going to use 20, 40, and 10. And then you solve this equation again by first combining your like terms on each side. And then I'm going to subtract 70 from both sides. And I get 3p equals 30. And then when I divide both sides by 3, I get p equals 10. So the probability of Tracy, James, and Katie winning is 10% each. And if you would like to check them, you can add all of these percents together, and indeed it adds up to 100%.